Hey everybody, we are back in Unit 6, Lesson 2, Angle Bisectors. This is Tennessee Revealed Geometry. Alright, so angle bisector, it's basically cutting an angle into two equal parts. Bisect means to divide it into two congruent things. Alright, so yeah, let's get into it. Okay, we can have an incenter, which means we're going to have a triangle with three angle bisectors that meet. Remember, we call those concurrent lines, but specifically for the angle bisectors, we call those that an incenter. All right, well, I doubt we're going to get to that very soon. Probably going to have a couple of examples before we get to that. All right. So here is a great example of an angle bisector. This is angle DBE, and it has been bisected by this ray BF. And you can see that those two little angles are marked equal to each other. All right. Well, I really like this this rule right here because if you connect the DF and the EF, they're going to be equal to each other, and also makes 90-degree angles, which is super cool. All right. So there's your converse. All right. Let's see here. Sorry, I got distracted. My cat just jumped up beside me, and now he's going to want to walk all over my computer. No, baby, this is not your time. All right, this is example number 1, you guys. And we're to find QT, which is this length right here. All right, well, I'm going to use the angle bisector theorem, which means these two things, 4x plus 8 and 9x minus 7 are equal to each other. I'm just going to figure out how they want me to write this. So ST, I guess they want me to put QT is equal to ST, which would make sense because that's how I'm going to solve this. All right, so I'm going to put 4x plus 8. Oh, they want me to write it in the equation editor. Fine. Here we go. 4x plus 8. And over here, ST is going to be the 9x minus 7. So 9x minus 7. All right. So they're equal to each other. Looks like they subtract 9x to the other side. So minus 9x cancels out the 9x. 4x minus 9x is a negative 5x. So I'm going to subtract 8 to the other side. So minus 8 here, minus 8 on the right side. So negative 7 minus 8 is a negative 15. And the opposite of multiplying by negative 5 is to divide by negative 5. So negative 15 divided by negative 5 is a positive 3. That is your x. And that is the number I'm going to start substituting with. Or what we say, plugging and chugging. Now remember, they want a QT. So I'm going to replace this x with a 3. 4 times 3 is 12. And 12 plus 8 is 20. So that's what QT is. And again, if you want to check your answer, you can plug in over here. And if you get a 20, you know you did something right. If you get something other than 20, you probably made an oops. So 9 times 3 is 27. 27 minus 7 is 20. So we are definitely good to go. We did great. All right, one other example, go online. Here is a check. All right, so we are trying to find SP. And since this is an angle bisector, these two parts, M to S and P to S, are congruent to each other. So I'm going to check to make sure my teacher notes are on. And I am going to add a note to set them equal to each other. 3x plus 5 equals 6x minus 7. Because I'm doing this one-handed because my cat has decided to lay on my left arm and is forcing me to love on him. And I'm not even going to bother trying to get him off of me because he's just going to jump back up here again. I know my cat pretty good. So let's see. I'm subtracting 3x to the other side. So 6x minus 3x is 3x. All right. I'm going to add 7 to the other side. So plus 7. I'm going to add it to the 5. So 5 plus 7 is 12. And equals 3x. And then divide by 3. 12 divided by 3 is 4. So my x is going to be a 4, everybody. That's the number I'm going to plug and chug to SP. So I'm going to take my 4 right there for the x. 6 times 4 is 24. And then 24 minus 7. Oh, my goodness. Let's see. 24 minus 7. That's going to be 17. All right. So if you want to check, make sure you plug that in over here. All right. So 12 plus 5 is 17. We are good to go. All right. Let's see what I got here. Example number 2. We want to find an angle this time. All right. We are looking for angle ZYW. ZYW, which is this little angle right here. Well, gosh, guys, this is easy. These two angles are equal to each other because that's what an angle bisector does, is it cuts the angle XYZ into two equal parts. So the answer is automatically 38 degrees. I'm not even going to try and solve this, you guys. It's just 38. So yeah, these two angles are equal to each other. So 38 degrees. Boom, done. Okay. You got to check, and they're looking for angle JKL. Same thing. Look, if this angle MKL is 37, then JKL also 37. I'm not going to pretend to, try and solve that. They're just equal to each other. Boom, done. All right. Okay, so I got another online activity. You're more than welcome to try that. I'm going to mosey on to the next page here. Okay, here we go for the end center. All right, so when you have concurrent lines, that's 3 or more lines that intersect at one location, and they are all from angle bisectors, we call that the end center. So P is our end center of these 3 angle bisectors: BP, CP, and AP. That is what an end center is. All right, so let's see here. Okay, let's just go on through the definitions. I'm going to skip all of that. All right, so we got an example here. Example 3 says P is the end center of the triangle XYZ. All right, that means that XP is an angle bisector, YP is an angle bisector, and ZP is an angle bisector. All right. So we got, okay, well, there you go. Just talk through all of that. Okay, let's see. We got angle LXK. Angle LXK is, sorry, getting distracted again. My cat has decided to get down. Okay, good deal. 2M, angle PXK. So it's twice this. Well, 24.6 times 2 would be angle LXK. So I need to multiply 24.6 times 2. So it's going to be 49.2. All right. Okay, so that 49.2 goes in for LXK. That's going to go in right there. All right, then it says, likewise, KYJ is twice the PYJ, so 25.1 times 2. And that KYJ is going to be, that's going to be 50.2. Plus LZJ, so plus this, whatever this angle right here is, this big angle Z, it's going to end up to be 180 degrees. And it looks like they want us to find what LZJ is. LZJ. Okay, well, double the 24.6 is angle X. Double the 25.1 is angle Y. And we're going to add those together and subtract from 180 to find the big angle Z, LZJ. All right, so 180 minus 49.2 minus 50.2. And it looks like it's going to be 80.6. Now, listen, you guys, if for whatever reason your teacher asked you for LZP, that's this little bitty angle, or JZP, that bottom little bitty angle, you take that 80.6 and divide by 2. That'll be what each one of these is. Because remember, an angle bisector cuts it into 2 equal parts. Oh, I didn't even look ahead. I guess that's what I'm about to do here. All right, so let's see. Because ZP bisects LZJ, That means I'm going to take that 80.6 and divide by 2. So I'm going to cut 80.6 in half. 80.6 divided by 2 is 40.3. All right. Let's see if I'm actually done with the problem now. Okay, good. I am. All right, so we're going on to the check. Gosh, after 26 years of doing this, you kind of know what's going to happen next just out of practice. All right, so I'm on to the check. All right, I actually get to turn the page now to see what problem we're actually on. Okay, so you guys, I'm in your workbook, page 359 at the very bottom. I can do that now because my cat has gotten off of my arm. All right, let's see what we got here. Find each measure if J is the end center of triangle ABC. So I got triangle ABC. All right, J being named the end center means that I have 3 angle bisectors. BJ is an angle bisector, so is CJ and AJ. They're all angle bisectors. So what does that mean? That means that 33.9 will also be 33.9 right beside it. 28.5 will also be 28.5 right there, right beside it. And yeah, see, so JAC. Okay, well, here we go. I need to find this big angle A by doing 3 angles of a triangle add up to be 180. And then because they want JAC, they want just this section of it, the one on the right. That means I'm going to divide by 2. I'll worry about JF here in a second. All right. So let me get my teacher notes out. So remember, 33.9 times 2. That's going to be 67.8 plus 28.5 times 2 is 57 plus, and I need to know what angle A is. So I'm just going to call it angle A for right now, equals 180. All right, so I'm going to subtract both of those numbers to the other side. And the big angle A, my apologies, 180 minus 67.8 minus 57 is 55.2. Now remember, they want JAC. They don't want the big angle A. What I just found are these 2 little sections together. So I'm going to take that 55.2 and I'm going to divide by 2. So it looks like my final answer, 27.6. All right, 27.6, everybody. 27.6 degrees. All right, now let's see. I got to find JF. All right, what do we got here? JF. I got to find that little section right there. Okay. Let's see. What have I got? I've got EA is 9.4, which means FA is 9.4. Oh, it's Pythagorean theorem. I see it now. I see it. All right, so look, I got a right triangle. I'm talking about triangle JFA. This triangle, JFA. I have JA, which is 10.6. That is your hypotenuse. I have this side, A to F, which is 9.4 because E to F is 9.4. And I am looking for JF, the little side of the right triangle. So this is a Pythagorean theorem. A squared plus B squared equals C squared. Now, because I do not have A squared, but I do have B squared, and I have the hypotenuse, this is a subtraction problem. So let me pull this back up. I'm going to get rid of all of this for you, my visual people can follow me. So A squared plus B squared equals C squared, but I don't have JF. So I'm going to leave that as A squared. All right, then I'm going to add it to the 9.4 squared. And that's going to equal my hypotenuse, and that is 10.6 squared. All right, I am going to do the opposite of adding. This adding 9.4 squared, I'm going to subtract 9.4 squared. So minus 9.4 squared will cancel this out. And then I got to do 10.6 squared minus 9.4 squared. So I'm just grabbing a calculator, and this is really what I'm putting in. 10.6 squared, that's to the power of 2, minus 9.4 squared. Again, that's to the power of 2, and I get 24. Now listen, you guys, the opposite of squaring is the square root. So the only way to get rid of this square is to square root the a squared, leaving just a. And now I have to square root 24. Now for you guys that are breaking down the radical, you should be looking at a factor tree, looking at numbers that are going to pair up together, and you're going to end up with 2 square root of 6. So I do not know if your teacher is happy with that, but 2 square root of 6 is a correct answer. And that's usually what the ACT is going to have. They're not going to have it as a decimal. So 2 square root of 6 is really what you want. If your teacher's okay with the decimal, typically they probably want it to round it to the nearest 10th or the nearest 100th. So I'm going to round that to 4.9. All right, so I do not know what your teacher's going to want. I like it both ways, but I make sure that my students realize that the 2 square root of 6 is what they're going to need to know for the ACT and for Algebra 2, which comes after geometry at our school. All right, example number 4. Looks like I'm getting ready to turn the page to 360. All right, so example number 4. All right, got it here. Sculpture be placed in the courtyard of a high school. The entrances to this courtyard are located at points A, B, and C. Find the location of the center of the sculpture so that it's equidistant from the sides of the courtyard. All right, well, they do this for me, and they want me to do the check. All right, I'll tell you what I'm going to do for my visual people. I'm going to open up my GeoGebra, and I want to prove that this example is correct. So let's see. I need to have, and they don't give me the order pairs, lovely. So I need to have a big enough for 0, 0, for 8, 8, and for a 15, 3. All right, so it looks like I'm all in quadrant 1. So I need 0, 0. I need an 8, 8, and I need a 15, 3. Okay, here we go. All right, I'm going to get a polygon, 0, 0, 8, 8, 15, 3, and back to 0, 0. All right, and I'm going to do angle bisectors because I want to prove that this is the incenter. 8.3, 4.4. All right, so if you've never done GeoGebra before, not a problem. It's the 1, 2, 3, 4th icon from the left. This pulls up all of our interesting thing for triangles, and I'm looking for angle bisector, which looks to be the 4th one down. So I'm going to click on angle bisector. Now I need to click on 2 lines so that it understands which angle I want to bisect. So if I want to bisect angle A, I'm going to click on side B and side C. And there's my angle bisector for A. I want to bisect B, angle B, excuse me. So I'm going to click on side C and side A. And there's my angle bisector for angle B. And the last one, angle C, I want to click on side A and side B. And there is my angle bisector for angle C. All right, this lovely thing. Everybody see these concurrent lines? This is an incenter. So I need a point right here to figure out if their answer is correct. So I'm going to come over to my second icon, select point. Boom, there it is. All right, looks like 8.29, 4.44 is the correct answer for the incenter. So 8.29, 4.44. And it looks like they rounded it. 8.29, they round to 8.3. And 4.44, they round to 4.4. All right, so their answer is correct. All right, so it looks like they're going to want us to do our own check. All right, well, no problem. I'm going to erase all of this in my GeoGebra. Have a 1, 0, 1, 10, and 11, 10. So let me back out. All right, so I need to have it big enough for 10 in both directions. So 1 0, 1 10, 1 0, 1 10, and 11 10. Don't forget to go back to your original. All right, so they're wanting me to find the center. Okay, so it looks like this one's in a hot tub. They're going to put a hot tub at the end center. And I need to find 3 angle bisectors to know exactly where it's going to be. All righty, here we go. Fourth icon from the left, angle bisectors, the fourth one down. Remember, for angle A, I need to click on side C and B. For angle B, I need to click on side C and A. And for angle C, I need to click on side A and B. And I have an end center exactly right there. Now, for the computer to tell me where it's going to be, I need to click on a point. Boop, there it is. So it looks like our answer is going to be 3.93, 7.01. I'm going to come back to see if they want me to round to the nearest whole number. All right, well, 3.93 is going to round to the nearest whole number 4, and 7.07 will round to the nearest whole number 7. So it should be 4, 7, everybody. 4, 7. And I need to have this as ordered pairs. 4, 7. All right, there it is, my lovely people. If you guys need another example, you can go online. But I believe the practice is coming up. Yes, it is. Okay, good luck, you guys. Give me a question if you have it, or ask your teacher. All right, have a good one. You guys take it easy. Bye.